Right, I'm going to give a talk on continuous deployment with Docker and the experiences gained going from dev through to production at British Gas, working on the successor to their Hive project. So it's quite a heterogeneous system. There's a lot of discrete components, and everything's packaged up into an image and deployed via Docker. So we've got Node.js as the core technology, Angular running the front end, and some mobile apps. We've got R for a data transformation pipeline, and some proprietary code from Java and Groovy developers. Containment, or containerization, we've got Docker and CoreOS, with Fig being used in development and test stages. For some reason, all our data technologies are red. And to prove that the code does what we expect it does, then we've got Karma, Protractor, which is a WebDriver-based library, Mocha, and JUnit. So the key principle when designing the pipeline for continuous integration is designing it in such a way that a partial or whole stack is deployable on the developer's local machine. So this aids full stack debugging. In a system with so many moving parts, it can be very difficult to find which layer a bug is when integrating components. So the ability to bring those up, either a slice or the entire system, means that the developer can prove that his tests are operating as he expects them without having to defer to the build server pushing to a staging environment or a test environment. And we have no staging environment, in fact. We use feature toggles. So in a continuous deployment style, if we want to show maybe someone in the business we've got a new feature or some new functionality, we just toggle on that user, the IP, whatever it wants to be. And we have a full system integration test as well, obviously, but they can be run on the developer's local machine. But due to the expensive cost of bringing up the entire stack from cold, service discovery, then making sure availability, or making sure they are available, it takes quite a long time. So in the interest of a tight feedback loop and saving context switching for the developer, we do defer that to the build server. Pick any two, we've gone for fast and good. And the core principles continues. The containers are identical from dev through test to production. Now, this isn't quite the case. The Docker file is consistent. The dev will build it on their local machine to run their suite of tests. The build server will then, at the beginning of the build chain, build that container, which is then pushed through various tests, various environments, finally through to production. But it comes from the same Docker file. Logic is branched environment variables. Being a node shop, we just use node_env. A deterministic pipeline is obviously key. If you have any non-determinism in your pipeline, then there's no point doing continuous anything. And constant cycle time optimization. The time between a developer thinking about a change, making that code update, pushing it to version control, and ending up in production. As more tests are built into the system at all different levels, then things invariably become slower. So just a constant eye on that to ensure that where things could be parallelized or sharded, we take that opportunity. So continuous delivery versus deployment. Continuous delivery is the principle of your code always being available to deploy to production and moving to a production-like environment, but not necessarily being pushed directly to production. Continuous deployment is the principle of no manual intervention, no air gaps. You make a change, it passes your automated suite, that's your production code. So the first tenet of this is all code must be testable. And as you can see, humans are fallible. Test teams, if they can be eradicated altogether, no offense to anyone in particular, we'd be much better off, and machines are all that will be left one day. So bringing pain forward, there's a lovely set of illustrations for Dave Farley and Jez Humble's continuous integration book, suite of websites, etc. If you're not familiar with them, then continuousintegration.com is the ground rules. And there's a set of four of those scribbles that really lay things out very plain and simply. And if you're not convinced of continuous delivery, they will do the magic. So, developer workflow. Developer starts off hacking some code, runs tests that they've written in parallel with that code, preferably before, but it's developer preference, commit to the build server, and relax. Or not, as the case may be. The build server is then responsible for running the suite of tests. So assuming that the tests have all passed, then we've got green light from the build server, and we start to push them towards, in fact, at this point, we push them into production. So this is more of an overview before I get into the specifics. And the way that we've dealt with this is we deploy the code alongside the current version. We balance traffic over using HA proxy, confd, listening to etcd keys to just slowly move that over, and we monitor the entire state of the cluster and the components in it, so error rates, latency. Also, we have a suite of exceptions tests for the component and the cluster at large, and if any of our key performance indicator tolerances are exceeded, then that deployment is marked as unstable, and we roll back to the previous known good state of the cluster. So, I'm going to detail how we've actually done this. We start with a shared code repository. So there are things that must be consistent across all the repositories, and that almost matches one-to-one to images, Docker images. So we start off with an NPM module. As I said, we're a node shop. It makes sense to do that. So we have this module and a package manifest present in all of our repositories, even our data store repositories. So linting rules, extensible task runner, etc. And what happens is once this is installed, in terms of installed as a dependency, it's got a post-install job that moves files into position. So it'll move the task runner base configuration, the linting code, etc. And the way that we extend those is by, essentially they're extensible by virtue of other files. So we don't edit any of those files. They're considered immutable. And any updates or overrides we want to do, we do by abstraction and extending those files, which means that we've got a constant upgrade path without having to worry about anything diffing or merging, etc. And because this repository of shared code is a dependency for more or less the rest of the system, any change to that will cascade build jobs across the rest of the system. So the task runner we've chosen is Gulp, again, Node.js based, and it's all in the interest of speed. You get a very tight feedback loop. We're able to parallel jobs are a first-class citizen. We found slight issues with hierarchical task dependencies, which will be addressed in version 4. It's a minor detail, but it's generally worked very well for us. And the key tenet here, or maybe the next one, is a unified task interface. So we've got a heterogeneous system of different technologies, and we're deploying them onto a Linux system. Everyone's using boot to Docker on a Mac. Ideally, we can abstract away all the changes between these environments in order for the developer or the build engineer to not have to worry about the minutiae of implementation of those environment variables. So the way this is done, Gulp has a task for everything, more or less. It's not necessarily actually coded in JavaScript. A lot of the time it's deferring onto further bash scripts, but it's a central point of focus for all the possible tasks running against the system. So we've got 4 different test runners, I mentioned. We've got from JUnit through to Mocha, etc. So we have a cross-platform bash script which abstracts away the differences between them. You can run test unit, and it'll look in the test/unit directory for the files in there and identify which which test runner is required to run them. So it can infer that either by config files or by introspecting into the files slightly. And this test runner then abstracts away options like JUnit XML output for the build server, quiet mode, etc. This, as with everything, is unit tested or exceptions tested using the bash automation test system. Highly recommended if you've got any bash code at all. It often slips through the cracks. And using this, we're able to test the differences between essentially OS X and Linux, which is all GNU. And this also means the build server has no logic. The build server is able to run gulp test, and it runs the same suite of tests without having to know how to configure them or set them up, etc., as the developer runs on their different box, on a different platform. So, dev to Docker. A developer develops a component with tests and then builds their own Docker file. We have a common base image with various communal tools built in, and then in the Docker file for the component, we'll add the source files as necessary. We won't add dependencies from outside, obviously because we're on different architectures here, different platforms rather. So the installation of dependencies occurs inside the container and has all the caveats as per, I've been mentioned a few times today already. And testing. So the test pyramid, I hope you're all familiar with. Unit tests covering the breadth of the system, integration tests less so, and system tests, the whole system, only testing user journeys, things that can't be tested lower down. The reason for that is they're much slower, they're more brittle, they're prone to failure, and you don't want to have to rely on those. So going back to the testing process, the first thing this test runner does is check for the presence of a bash script. And that bash script does global setup and teardown and has a test override hook, irrespective of the test framework being used. The reason you need to do this is because there's various things that you don't want to have to build into your test file itself. You don't want to have to call back to a contrived HTTP service that you've brought up specifically to set a fixture up, etc. So the setup script does some broad global configuration and then brings up external services required for the functional testing of that component. So each repository's fig YAML configuration file defines the component, missed an apostrophe, defines the component's invocation and that of any immediate dependencies. So the fig YAML of the component under test is copied to a separate file. Then the dependent components of that component, so for example, we have a contact center, which is an AngularJS application which relies on an API, which also has a transitive dependency on Couchbase. We don't want the configuration data for Couchbase to be in the contact center. We don't want to have to repeat ourselves, and it's a separation of concerns. So we just copy that data, merge it into the fig test YAML, and template through various environment variables. So we know we've got at least some form of consistency as well as we can guarantee it. As I say, we also use IPs and ports. This is because we're using fig YAML on single node servers here. This is either a boot to Docker VM or a build node on Jenkins build node. So various cross-platform complexities. Things like we check the presence of the services that fig brings up by grepping the output of fig PS, which on a TTY-less build server, fig was not very happy, let's say. So we had to emulate a TTY using the script command, but then this isn't cross-platform. So these funky cross-platform fixes are the secret sauce, the glue that actually allows this to happen. In my opinion, it's well worth it because we have more or less this. That's more or less the extremity of cross-platform issues that we have. And back to the test setup script. So at this point, Gulp has invoked a test runner, which has invoked the setup script for the tests in a repository. We've used fig to bring up the services and any of its dependent services as written in the setup script, and we have determined that the services that we want to bring up, fig has said they're up. Now, all that means is that fig has brought them up and the containers are running. We need to use HTTP health checks to check the health of those services, and we've got dedicated health endpoints on RESTful services to determine their availability. Try and avoid sleeping unless it's necessitated because it's just an unnecessary waste of time, and various other things that we have to do, authenticate, get OAuth tokens for our API, expose source labs, tunnels, etc., etc. So at this point, we have an image and its components, and we're looking to test the public interface of the primary image. So we don't care about its components because they've been through their own build process, and we're using the last good versions as pushed to our local or private Docker registry and brought down specifically. So there's a pull step in the setup script to make sure that our components have passed the build process, etc. So we test the public interface of the image. In terms of setting database fixtures, we bake them into a separate image, which we link through to Couchbase, for example, which again gives this uniformity. It means we don't have to install any Couchbase tools, just maintains the Docker paradigm. And on build server test completions, these will be functional and acceptance tests of a component. The image is tagged, and that tagged image is pushed to the private Docker registry. So at this point, we know that we've got an image that passes tests for its component. However, in terms of the system, so okay, we promote this at that point and we push it into a system test environment, system integration. So we can be sure that the contract we have with the tests, the test contract we have with the code as defined in the components tests, that's all passing, but maybe we've updated all the tests and the relevant, maybe we've made a backwards incompatible change in the component, and then we've got something else consuming that which doesn't agree. So we then push it to the system integration test environment. Assuming all's well and good, we have an isolated non-functional test environment which runs security performance. And assuming all is well here, the component is marked for deployment. Now, as we've spoken about a number of times today, this is verging on a black art, and orchestration is still nascent, let's say. So the current design that we've opted for is heavily informed by Kubernetes. In lieu of version 1, we've copied some of their principles. So we have service discovery via etcd. The HA proxy routing based on etcd, and as mentioned earlier, just gradually shifts the load across from one to another via conft. Cluster immune system is our addition to this. So in the case that any of our tolerances are exceeded, then we'll just bring that straight back again, and there is no more traffic to that component. And we'll also run component level and system level acceptance tests against the cluster in production. So just a bullet point list of broadly continuous deployment, not necessarily specifically here for Docker. Everything has to be testable. Pipelines have to be deterministic, otherwise you're shooting yourself in the foot. Deployment to production means that you're testing real code in a real situation. You can get it into users' hands instead of having to use a test team. Monitor everything from the application down to the infrastructure. KPIs for cluster immune system. Identifying what they are before starting the project is relatively tricky, so they tend to emerge. You can identify them when things go wrong, looking back in Graphite or whatever your logging system, whatever your visualization system would be, to identify what was exceeding whatever tolerance, and then put in something artificial and tune that over time. Rollback. Halting the pipeline is a good way to enforce this constant quality control. So 5 Whys is a Japanese sort of corporate style of, say, post-mortem debugging, but not necessarily in technical terms, across any incident. And it involves asking why to any answer to any question 5 times. Why did it go wrong? Well, because I wasn't given enough training. Why weren't you given enough training? Well, because management are incompetent, well, et cetera, et cetera. Write a failing test case before fixing it. It stands to reason, it's standard testing practice. And then at this point, with the failed pipeline, you can re-enable it and know that you've covered everything that you can possibly contractually oblige the system to do for you, and sleep well at night. Thank you.
Next question.
Hi. Hello. Forgive me if it's a stupid question. What's a cluster immune system?
It's a terribly trendy technical term. Essentially, it's the state of your cluster as dictated by the health KPIs that you've chosen. So it might be your response times, it might be your HTTP status codes, it might be your application error, log levels, things coming out, info, warning, error, etc. So yeah, it's an abstract term for the health of the cluster as dictated by the things in it.
Another question?
Hi. Do you use like separate registries, like one for images that have been passed tests and one for developers to share their stuff around, or?
No, everything. So we have 2 registries, one for NPM modules and one for Docker. I presume you're talking about the Docker registry.
Yeah, Docker.
Yeah. The developers actually have the capacity to push an image from their local machine to that registry. It's frowned upon because if it doesn't go through the build chain, then there's no guarantee of its quality. But in terms of separate registries, in terms of continuous integration, you're always building on trunk, and we've sort of extended that idea to everything. All our pieces of infrastructure are definitive. They're the only instance of those.
Next question.
How do you manage the versions? So you mentioned basically the build system tags the Docker image, but how do you manage knowing which version you should be deploying to which environment or that sort of thing?
So the last stage of the build process after non-functional tests is a call from Jenkins to a build bot, if you like, which holds a journal of all the requests made previously and also of all the activities that it's performed. So we've also based it on, again, Kubernetes intent system. So a post from Jenkins says, I have an intention to deploy this version of this service, and then that goes into the journal. There's two things here. First of all, if the whole cluster was to go down, it could be brought up in its previous state from that journal. And also, if things are rolled back, then obviously the journal's updated, and we're not just using the latest chronological version, but rather the latest version as tagged in that data store.
Next question.
So you're influenced by Kubernetes design, I say. So how does your architecture look like, and what is like the surrounding tools you're using? You're using Fleet?
Yep. We're using CoreOS. Yeah.
CoreOS. Okay. So all this standard stack, and what around that? What's your tool set, and how is it driven?
So when you say tool set, I mean
whatever you call it, your platform as a service.
Well, I mean, essentially, we're building our own platform as a service. In lieu of Kubernetes being available, generally available, let's say, we had a deadline closer than we were willing to take an external dependency on. So a lot of our design decisions are informed by Kubernetes, and that goes all the way down to we're using CoreOS, Fleet, etcd, confd, HA proxy. I mean, we even have a deployment bot equivalent to their pod manager. So it's very, very similar, but because we don't have development control of Kubernetes, it's not a risk that we can take in British Gas, essentially.
But is your manager and like the top level, is it Node.js also, or?
Well, it's very, like I say, it's heterogeneous. So Node.js is used for applications. We've got some HTTP repeaters. We use it as sort of glue in between various things. At the point that the data comes into our system, it's being posted over HTTP into some proprietary Java services that are outside of our control, but we, again, containerize them and put them through our build process with functional tests, testing the interface of the image. Then we've got R going in our data transformation pipeline. I mean, is that a suitable answer?
Exactly, I would see like an architectural diagram more or less, but this is of course not possible right now.
No,
so
it's probably commercially in confidence for a while.
Hello. Yeah, I have a question that's somewhat related to the chap asking for the architecture, but how did your experience with continuous deployment inform the application architecture of a tool? And I'm specifically thinking about persistence and the need to roll back and things like dropping columns in tables and other such events. Well,
as we all know, database version migration is hellish. And we've avoided it by going schemaless, actually. It's all NoSQL based. So we don't have any column migration. In terms of the sort of de facto answer to that, the way that Etsy, for example, who are prolific in their publications on their internal engineering culture around continuous deployment, if they were to do a column migration, they duplicate the column, so maybe they've changed the column width, and have the application copy the data into the new column, but they run with both columns in that data for a reasonable amount of time, which is, to my knowledge, I have no idea what that reasonable amount of time is. Then at the point that they've moved sufficiently past it that they're confident that everything is migrated, they'll then drop that column in, I guess, a scheduled maintenance or something. In terms of how continuous deployment influences the architectural decisions, obviously everything has to be backwards compatible because we're potentially running two versions of the same service in production at the same time. And we want consumers of that service to be able to ask or consume it in, say, both formats. So it means that the backwards compatibility element is it's pushed to the fore, and we have to make some compromises because of that. But I think broadly the compromise of quicker delivery, blah, 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 all those benefits outweigh the sort of developer overhead. But it is very much something that has to be at the front of the mind.
Brilliant. Please have a big hand for Andy.